Good morning. We're at the Glenlea long-term plots. It's July 31st, 2019. My name is Martin Entz, and we're at the University of Manitoba Glenlea Research Station. We're making this short video because we unfortunately had to cancel the field walk this year due to the one big rain we got. It made the road impassable. And so we're substituting this short video instead of the tour, and I'll be taking you through the plots and giving some highlights of the research this year. So just a quick reminder, the Glenlea long-term study has two crop rotations, both under organic and conventional production. So the first crop rotation just has annual crops. And in the conventional system, it consists of soybeans, which are behind me. And you can see the soybeans this year look rather short. It's been another extremely dry year at Glenlea. And then the soybeans are followed by wheat, which is over here. And the wheat crop looks quite typical of what farmers are experiencing in the area. And then we have flax, and we'll go over and look at the flax plot. And I'm going to measure the height of the flax crop just for comparison purposes. And it is, if I just do a random sample here, it is about 60 centimeters tall in the conventional grain-only rotation. And then the flax is followed by oats. And we have some herbicide-resistant oats in this rotation. So this is the grain-only conventional rotation, and it kind of mimics what farmers in the area are doing. Now we're in the organic version of the grain-only rotation, and this rotation, instead of having soybeans as the legume, we have a green manure. And so we have a green manure, then wheat, then flax, and then oats. Now the green manure crop we're growing is a mixture of hairy vetch and barley. And the way we manage this crop is to grow the two together. And it was an extremely dry year, following an extremely dry year of 2018. But this system actually works quite well. We've got the barley crop didn't grow very vigorously, and that's quite typical because there's not a lot of nitrogen at the end of the 4-year rotation cycle. But we've rolled the barley, and now we can see the hairy vetch is growing very well, and it will grow right up until freeze up. It'll grow well into October, and it should be able to make, at least 100 to 120 pounds of actual nitrogen for next year's wheat crop. So there are many different green manures to choose from, but we've really been happy with this barley hairy vetch system. And in a moment, we'll go take a look at the wheat, which was seeded into this material. So now we're in the year after the hairy vetch. We're growing wheat. It is quite a short crop. If we look at the height of this crop, it's only 65 centimeters, but that's because we've had a terrible drought. But what we've generally seen at Glenlea is the wheat after the hairy vetch has yielded very well, 35 to 50 bushels per acre in the organic system, because the hairy vetch supplies a lot of nitrogen to the system. And the other thing that I'm observing here is weeds. We have a few wild oats, but they're not terribly bad. There's a few thistles, but not too bad. A little bit of quackgrass and also some yellow foxtail. But the crop is quite clean. What it's really lacking this year is not nitrogen, but water. So after the wheat in the organic grain-only rotation, we grow flax. Here is the flax crop behind me. Again, in terms of weeds, there are some wild oats, but it's quite surprising. After 28 years, we are not overrun with wild oats. The flax is about 60 centimeters tall, a similar height to the conventional grain-only system. but perhaps not as thick, and there are some quackgrass weeds and some yellow foxtail in here. So this is, again, to remind us of the rotation, it's hairy vetch, and then wheat, and then flax, and in a moment we'll go see the oat plots. So here we have the fourth crop in the grain-only organic rotation. It's oats, when we look at the crop, it's water limited. We do have some thistles, again, some wild oats, but in terms of weeds, it's not that terribly bad. It's short because it's limited by water. Now, historically, if you've been to the rotation in past years, you've seen oat crops that are very, very poor in this rotation. That was when we used to use peas as a green manure, and they just didn't supply enough nitrogen. So when we had the peas and then the wheat and then the flax, by the time we got to the oats, there simply wasn't enough nitrogen to grow a good cereal crop. Since we've used hairy vetch in the rotation, we've increased the productivity of this oat crop, which is 3 years after the hairy vetch. And that's because that hairy vetch simply supplies more nitrogen. And so in a rotation where you have a green manure only once every 4 years, we have to make sure that that green manure supplies more nitrogen than a pea crop could. We don't do it in the rotation, but it would also be interesting to grow some cover crops. Like, let's say after the wheat, we could grow a red clover cover crop or a lentil cover crop to add some nitrogen to the rotation. That's another way to increase the nitrogen supply to these organic systems. But what we've learned in this grain-only organic system is it's been okay. It hasn't been the most productive because of lack of nitrogen. In terms of weeds, we do inter-row cultivate these plots, and we've definitely improved weed control over the 28 years. Here we are in the second rotation system at Glenlea. We call this the forage grain rotation. It contains 2 years of alfalfa, and then wheat, and then flax. And again, we have the rotation under conventional and organic production. So here we are standing in front of the conventional version of this forage grain rotation. And beside me here is the first year alfalfa crop. And it was established this year, and there are little alfalfa plants in here. Because of the drought year, it hasn't produced that much biomass. It's been mulched once, but it will be cut for hay later on this fall. So this is year 1 alfalfa. Let's go take a look at year 2 alfalfa. This is the second year of alfalfa, and you can see it's a very productive crop. It's I'll just measure the height. It's about 55 centimeters tall. It's been cut once already for hay. It'll be harvested again probably this week. This crop is fertilized with phosphorus and whatever other nutrient it needs other than nitrogen. Of course, it fixes its own nitrogen. And it's very weed free. And this looked like that year 1 alfalfa plot that you just saw. When we establish alfalfa, there's always a lot of weeds, and we cut them, and by year 2, it's a nice clean crop. So alfalfa, even in the conventional system, it's a cleanup crop. It's a good way to control weeds. Now this is, we're in the forage grain conventional system. This is the wheat that follows alfalfa. It's a crop that you'll notice it has no wild oats, and that's one of the nice things about having alfalfa in a conventional rotation. It just really makes the wild oats go away. They never really become a problem. It has been sprayed with phenoxy herbicide, and the fertilizer rate in this wheat crop, it's been fertilized to a 65 bushel per acre crop. The fertilizer requirement in this rotation is about half as the conventional grain-only rotation. So we're getting quite a bit of nitrogen from the alfalfa. We had some difficulty controlling the alfalfa last fall. It was a drought fall, it's been a drought spring, and you'll see there's been quite a bit of alfalfa regrowth, which I'm not really happy about, but that's just the year. Okay, now we'll go take a look at the flax, and we'll just walk over, and there's the flax crop, which follows the alfalfa. You know, your typical flax crop. I'll measure the height. It's about 55 centimeters tall, so it's about 5 centimeters shorter than the flax in the grain-only rotation. I don't know if it's going to yield less. It's a good-looking crop, but perhaps one of the reasons that it's shorter is than the flax in the grain-only rotation is water. Having alfalfa in the rotation does cause us to use more subsoil water than when we just grow crops like soybean and oats and wheat. And now that we're in a second drought year, the flax may be suffering some water shortage. So this is the forage grain rotation in the conventional management system. Its features are that it has fewer wild oat problems. It requires about half as much nitrogen as the grain-only system. And now we'll go look at this same rotation but under organic management. Here we are in the forage grain rotation, but now we're managing it organically. So again, I'm standing in front of the plot where the alfalfa was established this spring. You can see it's been mulched. There are alfalfa seedlings in there, and we'll be taking a hay cut at the end of the season. And alfalfa is always so surprising because we've had a little bit of rain, and my prediction is that it'll be about this tall in early September, and we'll get a nice hay crop out of it. So let's go look at the second year alfalfa. So here we are at the second year of alfalfa in the forage grain organic rotation. And we can see in terms of weeds, there are more weeds than we've experienced in the conventional second year. There's a little bit of quackgrass. There's some thistle. Let's measure the height of the alfalfa. It is about, it's about 40 centimeters tall over here. It's already been harvested once for hay. And if you look carefully, well, when I look at it here anyways, it looks like a disappointing second cut. And if we look at the back part of the plot, we'll see that the alfalfa is actually quite a bit taller. And let's walk over there, and we'll may have some movement on the camera, but it'll be dramatic to show you the difference. So here we have alfalfa. It's quite weedy. It's short. And the back half, we can see, certainly from where I'm standing, I can see a much healthier crop. And if I measure the height of it, it is almost 60 centimeters tall. So it's 15 to 20 centimeters taller than over there. What happened? Why is this part of the alfalfa plot so much better? Well, it's because we add composted beef cattle manure to half of the organic forage grain plots once during the rotation cycle. So this half of the plot has received nutrients from the manure, and the other half has never received any amendments. And what we've experienced in this rotation, as many of you will know from having come and visited the plots, is that when we harvest the alfalfa hay and remove it, we're removing a lot of nutrients, and we have created a phosphorus deficiency in that half of the plot. And so we split these plots about 12 years ago, and this is where we add about 80 kilograms of actual phosphorus once during the 4-year rotation cycle. So we add the compost to the first year alfalfa in the fall, and so this had compost added last fall. Okay, and now we'll go look at the wheat crop that's growing after this alfalfa. Okay, so here we are in the wheat following the organic alfalfa. And if we look at the wheat, the weed spectrum is not too bad. There's a little bit of quackgrass, a little bit of wild oats, unfortunately some volunteer alfalfa. But you'll notice the wheat looks pretty poor here. Actually, it's only about 40 centimeters tall. But if you look at the back of the plot, the wheat crop is much better. And so you've already, if I were to ask you to guess which half of this plot had historically received the composted manure, you would probably conclude it was the back half, because the wheat looks so much better there, and you would be correct. So what we notice in this rotation is that if we do not add nutrients to the alfalfa just doesn't make enough nitrogen to grow a nice big wheat crop, because this wheat crop is probably limited more by nitrogen than it is by phosphorus, although phosphorus would also be playing a role. So what we've really learned in this rotation is if we try to grow organic wheat after a poorly fertilized organic alfalfa hay crop, the yield is disappointing. That nutrient is really required to grow a big wheat crop. So that's the wheat after the alfalfa, and now we'll just turn the camera over here and we'll take a look at the flax after the wheat. And I have to say, I know I'm supposed to be a scientist and very impartial, but let me say I'm very proud of this flax crop. This is a beautiful organic flax crop. It is 65 centimeters tall. This is the tallest flax crop of any of the rotations, because remember, the flax and the grain only conventional was about 60 centimeters. The flax in the forage grain conventional was about 55 centimeters, and here this one is 65 centimeters. What's going on? Why is the flax growing taller where we have the alfalfa in the organic? That's a good question. Our data shows that the soil health is the best in this system, where we have the 2 years of alfalfa, and wheat and flax in the organic rotation is where we have our highest levels of microbial biomass carbon, even higher than when we put the alfalfa in the conventional rotation. And so we have more living organic matter, and that may have allowed this plant to grow better, to store more water, and overcome the drought. There's one other feature of this rotation, of this crop here, and that is it's very difficult to see which side follows the compost treatment and which side follows the unfertilized, the unmanured crop. So if we walk along the plot, I don't have my plot plan with me, and I don't have these exactly memorized, and things are randomized here, but my hunch is that that is the unmanured section, and over here is the manured section. And I'm if we look at the crop, but I don't know exactly. Actually, I'm going to change my mind. I think this is the unmanured section. It's a bit shorter. But my point is not to sort of guess which side is the manured. My point is that the crop really doesn't look dramatically different. And so why is the flax able to grow over here? I now am remembering that this is the unmanured side. Why is this flax able to grow reasonably well here where it's unmanured? It's about 60 centimeters tall. And that is because flax is highly mycorrhizal, and even though there's very little available phosphorus here, the flax can associate with the soil fungi to go get the residual phosphorus. And so this is a trend that we've noticed year in, year out, is that the wheat really responds to the composted alfalfa, whereas the flax doesn't. So that's the tour. Thank you for watching the video. It would have been nicer to be able to share this with you in person, but like I said, our field walk needed to be canceled. And so now you've had a chance to look at the plots from 2019. So I wish you all a great harvest season. And if you're watching this video in the winter time, perhaps we'll see you in the summer of 2020. Goodbye.